Hi folks, today we're going to talk about quartiles. So let's get started. So when you're taking a data set and you have it written in increasing order and you want to divide it into four equal parts, we call each of those parts quartiles. So the first quartile we'll denote by Q subscript 1, and that'll have approximately 25% of the observations below it and 75% of the observations above. The reason for the word approximately here is because sometimes some funky data sets can happen. So say we have a data set where every data value is the same. In those cases, you'll have more than 25%. So this is just set as a minimum, essentially, is this 25% for our first quartile. And moving into our second quartile, we actually have a better name. So it's 50% below, 50% above in terms of the number of data values. That's actually better known as the median. And then we get to our third quartile. That will have 75% of the data values below and 25% above. We'll denote that by a Q with a subscript of 3, and we commonly refer to that as our third quartile. And finally, we have our fourth quartile. We'll notice that would be 100% below, so that's actually going to be our maximum, essentially. So we just talk about these first three quartiles, and getting these values actually give us some information about the data set. And so that's what we're going to actually look at, is how to compute these first and third quartiles. We already know how to calculate the median. So we'll get started. However, we have some discrepancy between these two methods, and what it is how they go about making these calculations. So one example is, well, since it's approximately 25% below and 75% below for the first and third quartile respectively, we could calculate with the percentiles. So 25th percentile calculation, which you recall is k over 100 times the quantity n plus 1. So k represents the percentile and n represents the number of observations. So that's one method for calculating this. And another one that's a little more common in the literature is taking a median of medians. And what this is you start with finding the median, and then you have data values to the left of the median. And in order to calculate the first quartile, you take all the data values to the left of the original median, and you take the median of those data values to the left. Same thing for the right. You now look at the data values to the right of the median, and you calculate the median of all those data values to the right. So we're going to try both of these calculations in the data set, see how they work. Now, the following stem plot, that gives our weight in pounds of dogs that visit the veterinarian's office on a Tuesday. So notice your first entry here with 0 being that first stem and the leaf being 8. And the 8 represents a 1, so you have 8 pounds, 9 pounds in that first row. In the second row, that you have 12 pounds, 18 pounds, 18 pounds, 19 pounds, and 19 pounds. So now what we're going to do is use method 1 to calculate the first quartile. So using that method, notice we're just looking for the 25th percentile. That means our k value for percentile is 25, and our n value, well, we just need to count the number of dogs that visited the veterinarian's office, and we can do a quick count and see there's 28 different values. So you have n equals 28, k equals 25, so the location of this is actually 7.25. So now all we need to do is find the 7th and 8th data value. Well, you can count, you start with 8 pounds, 9 pounds, so on and so forth. The 7th position will be 19, the 8th position will be 25. So with that in mind, we want to go 1/4 of the way, so we start with 19 plus 1/4 of the way between 19 and 25, so we go 0.25 times the quantity, 25 minus 19, and that'll give us our first quartile of 20.5. Now, let's see if the method 2 actually gives us the same value. So in method 2, we first need to find the median. Well, we know there's 28 data values, so if you plug that into the formula for the median, you'll find that you take 28 plus 1 and divide by 2. That should be the location of the median. That's approximately 14.5, or actually exactly 14.5. So I'll denote that by an asterisk in our little data set. Now we want to look at all the data values to the left of the median. So we'll highlight those real quick. And so taking a look at these are the values we want to calculate the median of. So notice there's 14 data values sitting inside of here. So with that in mind, in order to calculate the location of the median of the 14 data values, that should be at the 7.5 spot. So we have to count out 7.5. Well, notice 7.5 occurs between 19 and 25 once again. However, here's the big difference. We only want to go halfway this time. And going halfway between 19 and 25, you just take 19 plus 25 and divide by 2, or another way to think about that is multiply by 1/2, which is 0.5. So we end up getting 22 as our first quartile. So this doesn't match our previous answer of 20.5. So let's check and see, maybe they do match up on the third quartile. Well, the third quartile, if we use method 1, that's just the 75th percentile. So the only difference from our method 1 for the first quartile, we'll change the 25 now to a 75. So K is 75, our N remains 28. And so we get, our location should be the 21.75 spot. So that's between the 21st and the 22nd observations, which those occur at 52 and 54, I believe. So 52 and 54 happen to be our examples. So now we want to figure out our third quartile using this method. So the way we do it, we want to go 3/4 of the way between 52 and 54. So we take 52, add 0.75 times the quantity, 54 minus 52, and notice that gives us 53.5. We can do Q3 again using method 2, and so once again we'll put our asterisk there. Actually, our median's in the same spot, so now we're just looking at the data values to the right. So it's these highlighted values right here. So of those data values, so notice we have 30, 31, 31, so on and so forth. Remember, it's still 14 of them, so it's going to be 7.5 to the right. So that means, though, in the position, if you take 14 plus 7.5, that makes 21.5 is where it will actually occur. So keeping that in mind, that's between 52 and 54 once again, and so we only want halfway this time. So that's going to give us a third quartile of 53. So these different methods give actually different answers, and that's what we want to call out here. Is method 1 gave us a first quartile of 20.5, whereas method 2 gave us a first quartile of 22. Method 1 gave us a third quartile of 53.5, whereas method 2 gave us a third quartile of 53. So there is going to be some differences between these two. Keeping that in mind, which one will we use most often? Well, we're going to use method 2 as that seems to appear more often in the literature, but not saying it's a right or wrong. Just kind of keeping in mind that you may see when you're reading up on this material some different sort of results, and it could be due to this difference in methods. So moving forward, where we want to go from here, what can we do with these quartiles? Well, what we can do is if there is a spread, so notice, remember we said it was the first and third quartile was an approximately 25% for the first quartile below, and it's approximately 75%. Well, if you do have a spread out data set, what we can start to do is check for outliers. And the way we do this is we actually start by calculating an interquartile range, and that's just by taking the third quartile and subtract off the first quartile. And then we look for outliers by multiplying that value by 1.5, and that'll actually give us an idea for suspected outliers if we go 1.5 times that interquartile range before the first quartile or beyond the third quartile. So let's see this in action. We're going to look at bluefin tuna. So here's the tons of bluefin tuna caught in the Mediterranean Sea over the past 11 years, with the leaves of the stem plot representing thousands. Okay, so keeping that in mind, we have the first one. This might be a little bit different than before. It's 21,000 because we have 21 is what it seems like our stem, but each leaf represents thousands, so it's 21 times 1,000, 21,000. Our second entry is 27,000. Third entry is 27,000. So what are the quartiles of this data set? Well, when you take a look at what happens, you see this highlight mark right here in bold. So that 30,000, what that is actually representing is the median. And the reason why, we can calculate that median, its location, since there's 11 data values, take 11 plus 1 divided by 2, that's 6, and so that median is 30,000. Now we want to look at the values to the left and to the right. So there's only 5 values to the left, and meaning 5 values to the right as well. So with that in mind, we take 5 plus 1 and divide by 2. That gives us 6 divided by 2, which our location is 3 to the left of that median and 3 to the right. That's the third and ninth spots for our location. So if you just look at those, the third and ninth spots are just 27,000 and 33,000, and those are our answers for our first and third quartile. Now, taking this to check for suspected outliers, this is where the fun begins. First, we need our interquartile range. So we found our first quartile was 27,000 and our third quartile was 33,000. This gives our interquartile range by subtracting those two to be 6,000. So, keeping that in mind, we want to take 1.5 times the 6,000. That's going to be 9,000. Now we want to see before the first quartile, 9,000 before, and then 9,000 beyond the third quartile. So notice in this case, if we take our first quartile and subtract 9,000, we get 18,000. However, our minimum in our data values is 21,000. So we're good there, actually. There's nothing that goes before 18,000. So that seems like no suspected outliers on the low end. However, on the high end, if we take our 33,000 and actually add 9,000, we stop at 42,000. So 42,000 is short of the 68,000 that our tons of bluefin tuna actually reach. So what this means is 68,000, since it extends beyond our interval, and our interval being 18,000 to 42,000, that lies outside of that interval, all of a sudden we know 68,000 is the suspected outlier. And these are the reasons that we actually look at quartiles. They give us some information about the data set, and we can get an idea, not saying it's always correct, but get an idea of what might be a suspected outlier.